Hello everyone, welcome to my channel. If you are seeing my video for the first time, do well to subscribe and turn on the notification bell. Thank you. So here is a question for us. And how do we solve this? The question says, a single phase half wave AC voltage controller has a load resistance of 50 ohms. The input AC supply voltage is 230 volts RMS at 50 Hz. The input supply transformer has a turns ratio of 1:1. If the thyristor T1 is triggered at alpha equals to 60 degrees, then we have to find the average load voltage and current. Question 2, we have to find the RMS voltage and IRMS current. And also we have to find the power factor. We are also to find the input power and output power. So how do we solve this? Well, the first thing we are going to do is to analyze the circuit diagram. And of course, we can see that the thyristor T1 is forward biased during the positive half cycle of input AC supply. So when T1 is triggered, it conducts and the load current flows through the thyristor T1. Current flows through here, through the resistor, then back to here. So the D1, this diode is reverse bias, so it won't conduct. So the equivalent circuit diagram of the positive half cycle is, we have something like this. So the T1 is closed now. The diode is open. Then we have our load resistor here. This. So for the positive half cycle, this is what we have. Need the secondary voltage. We have primary voltage here. This is T1, D1, then we have the RL here. So the direction of the current is like this, right? This is for the positive half cycle. Positive half cycle. So for the negative half cycle, we have this, and of course T1 won't conduct now because it will be reverse bias, but D1 will conduct. Then we have this is our RL, D1, T1, VS, and now this become positive, negative, V primary and V secondary. Right? So this is what we have on the negative half cycle, and the direction of the current is like this. Right? So the timing diagram of this is, we have, these are supply voltage, something like this. Right. So these are VS, and you know that conduction won't start from 0, right? This is 0, we have pi here, we have pi here, we have 2 pi, and our V average is, the V average now, conduction will start from 0, it will start from alpha. See, alpha is somewhere around here. These are alpha. So the conduction is like this. This is pi to 2 pi. You have 2 pi here. So if you want to find the expression for V average. Now we need to integrate. V average will be equals to the integral, that is 1 over 2 pi, because that is the total period, 1 over 2 pi integral of alpha to 2 pi Vm sine omega t d omega t. And of course we can take, because this place is pi, and of course we can integrate using this. You can use this from alpha to pi, then your supply voltage plus the integral from pi to 2 alpha supply voltage, right? So if you integrate with this, and as well as integrate this also, you are going to have the same thing. So I find the integral, taking the limits from alpha to 2 pi more simpler. So I'm going to get away with this. So let's integrate this. We have V average equals to 1 over 2 pi multiplied by Vm. We are taking Vm outside. Then if I integrate sine omega t, I will have minus cos omega t. Then this is the limit, pi to alpha to 2 pi, sorry. So the V average now becomes Vm over 2 pi, then minus cos omega t. If I'm to plug in 2 pi, here we have minus cos 2 pi minus, then minus cos alpha, of which this gives Vm over 2 pi minus cos alpha, we have cos alpha, then cos 2 pi, because pi in radian is 180 degrees, so 2 pi is 360, cos 360 is equals to 1, right? Cos 360 is equals to 1, then minus cos 360 give us minus 1. So we have Vm over 2 pi cos alpha minus 1. So this is the expression for my V average. So now we have our V average. Question 1 now. Question 1, because it's asked to find V average. V average equals to Vm over 2 pi. But Vm, we know that Vm equals to Vs root 2. And of course they give us Vs to be 230. So we have Vm equals to 230 multiplied by root 2. So we have 325.27 volts as our Vm. So we have 325.27 over 2 pi cos alpha. They give us alpha to be 60, right? So we have cos 60 minus 1. So if we put this into our calculator, we are going to have minus 25.88 volts. You can see your average voltage is negative, which makes sense because the negative half cycle always conducts through D1, and of course it contributes more negative than the positive controlled conduction. So if we have a negative answer for our V average, it does make sense. So the load current now is V average over our load, which is minus 25.88 over 50. So we have our I load equals minus 0.517 amps. Alright. So this is our I load, right? So let's move to the RMS load voltage and current. So we know that VRMS equals to 1 over 2 pi then integral
alpha to 2 pi
Vm squared sine squared omega t d omega t. And we have the square root of it, right? So if we want to integrate this also, we have Vm squared over 2 pi. Don't forget we have a square root here. Then the integral from alpha to 2 pi. Don't forget sine squared omega t is the same thing as sine squared omega t 1 over 2 cos 1 over 2 1 minus cos omega t. So instead of writing sine squared omega t, I will write 1 over 2 1 minus cos 2 omega t d omega t. Sorry, we should have 2 here. Cos 2 omega t should be here. So by integrating this, we have Vm squared over 2 pi multiplied by half. So this should be Vm squared over 4. Vm squared over 4 pi. Then the integral of 1 minus cos 2 omega t will have omega t minus sine 2 omega t over 2. Then limit from alpha to 2 pi. Then we still have our square root, right? So taking the square root of Vm squared, we have Vm over 4 pi over square root of 4 pi, right? Then we have the square root
So substituting 2 pi for omega t, we have 2 pi minus sine 2 multiplied by 2 pi is sine 720 over 2. So sine 720 is 0. So we have 0 here.
then minus omega t as alpha. We have alpha minus sine 2 alpha over 2. So we cannot say Vm then square root of 2 pi minus alpha plus sine 2 alpha over 2. So this equals to the VRMS. So don't forget we have alpha to the 60 degrees. So if I want to write 60 degrees in terms of pi, it's going to be pi over 3 because pi equals to 180. And 180 divided by 3 is 60. So 60 degrees is the same thing as pi over 3. So we have our VM to be 325.27, right? Then we have square root of 2 pi minus pi over 3 plus sine 2 alpha. That is sine 2 times 60 is 120. So we have sine 120 over 2. Don't forget we have square root of 4 pi here. So this is the same thing as, then plug in 2 pi, do 2 pi minus pi over 3 in your calculator. Normal pi in degree, that is 3.142. Do it the same thing, you have 5.669, then multiply by 325.27 over square root of 4 pi. Then you are going to have your VRMS will be equals to 218.47 volts. So IRMS equals to VRMS over R load, which is 218.47 divided by 50. So we have 4.37 amps. So this is our root mean square current, and this is also our voltage root mean square voltage, and this is root mean square current. So the next question is to find the power factor. The power factor, the power factor of PF is equals to the wave power over the apparent power, which is the same thing as P over S. Then the formula for the wave power is wave power, we're going to write RP. Wave power is I squared multiplied by R. Which is the same thing as 4.37 squared times 50. So we have 954.85. Then apparent power, alright, AP is simply VI or IV. So add VS, the input voltage, that is 230 volts given from the question, multiplied by I, which is 4.37. So we have 1005.1. Forward we have watts. So the power factor is equals to P over S. Real power multiplied over apparent power. So we have 954.85 divided by 1005.1. So this gives 0.9498. So this is the apparent power answer. Sorry, the power factor answer. So the next question is to find the power input and the power output. So the power input is simply the apparent power, right? So the power input is simply the apparent power, which is this. This is our power input. Power input is same thing as this, right? Power input, same thing as this. Then power output is the same thing as this. Power output. Power output, and this is our power input. Power input. So if you like this video, share it with your friends, and also tell us what you think in the comments. Thank you.